This is a prototype Bluetooth adapter for Psion Organiser. I thought I'd have a go at making this, and the idea is that you've got a Pico here, Raspberry Pi Pico, some level shifters, that goes into the top slot connector here. You've got a Wi-Fi Bluetooth module there, same one I used on the Organiser 2 recreation. Battery and charger socket here, and over here there's a power path type battery charger regulator. So one of the problems with this is this footprint here is a UFN 12, which is, well, it's not really my favourite to solder on. So I had a couple of goes at soldering it on, and I think it's okay actually. I think if you just tin the pads lightly and then use hot air, I think that does actually make connections. So I have actually populated one of these. I've got it here, and you can see there's the Pico, the Wi-Fi module, the battery, and you can see that it's currently got a red LED and a green LED on there. The green LED means that there's DC in from this socket here, so I'm charging the battery at the moment, and the red means that it's charging the battery. So you can see that it's definitely a prototype. There's a lot of wires and a bit of extra circuitry on the back, and some more wires. Another module there, and a whole host of connections that I've had to put on to correct various problems with the circuit. There's also OLED display, which I don't think will be on the final board. That's just for debug, just so I can see what's going on. So some of the problems I had, well, one problem, a simple one. I had some regulators here, and the regulator circuitry wasn't actually right on the circuit that I designed initially, so I've reconfigured it. And now the way that the power works, you have DC coming in from a charger here, which goes to a DC-DC converter. That's just a module. I think I'll probably leave connections for a module rather than putting that on the board, because that's a little bit more flexible in terms of getting parts and things. And it's also much more repairable than a chip like that. But anyway, this drops the whatever the charging voltage is, and this module can go up to 23 volts. That drops it down to about 7, which then goes into a 5 volt regulator here, an AMS 1117 5 volt version. That then sends 5 volts into the power path regulator. Now that is only a regulator that can drop voltage. This is dropping voltage, this is dropping voltage, this is dropping voltage. So this power path regulator lets you take the 5 volts in and the battery voltage, and it provides a supply between battery voltage, whatever that's dropped to, maybe 3.2 volts, up to 5.5. That's 5.5 that's selected by the particular chip that you use. This device has various different voltage outputs. You buy a different chip, a bit like you buy the AMS 1117 in different preset voltages. Turns out the only one I could actually buy, because of the chip shortage, was a 5.5 volt one, which isn't really a problem. So what you have coming out of there is either battery voltage or supply voltage coming through from the charger. If you've got the charger plugged in, it will charge the battery and supply voltage. So coming out of here you have 3.2 to 5.5 volts, which actually, if you put it through a diode, works very well with the Pico, because the Pico has a buck boost regulator, so it can accept higher and lower voltages than the 3.3 that it wants to actually generate. And that means it can take the input from this power path regulator and convert it, whatever it is, whether it's lower than 3.3 or higher, it can actually convert that into its 3.3. That 3.3 then comes out and powers the Wi-Fi module and anything else that needs 3.3, these level shifters here. And seems to work. Now the reason I've got this DC-DC converter is that the 5-volt regulator was getting very hot when I was running on 12 volts because it was dropping so much voltage when I had the Wi-Fi module on. So I'm hoping this is going to work better, and this will actually drop quite a lot of the voltage so that the 5-volt regulator doesn't have to dissipate so much current. So it's pretty robust as well. You can put up to 23 volts in here. There's a diode there for reverse voltage protection. You've got the DC-DC converter, the buck converter there, which is dropping down to 7 volts, and then you've got a linear regulator which should take any noise or any voltage transients out. Then you go into another regulator, the battery power path regulator. And the reason I used the power path one was because the Pico datasheet actually recommended using that sort of regulator if you're powering the Pico from an external supply, so I did. So it's quite complicated, but seems to work well. It's quite flexible. So at the moment I'm charging the battery. I don't really want to pull this out. I'm doing a charge test to make sure it stops charging, and everything seems okay. There's a little bit of heat coming off this sort of area, which you'd expect from the 5-volt regulator and maybe the DC-DC converter. So in terms of code, this is running the top slot adapter code in here that's been modified to become a Bluetooth adapter bit of code. And at the moment everything from the Pico to the Psion seems to be sort of working. I'm getting some garbage characters, but there you go. I think that's just some sort of setup. Now I've had to add this because when the hardware is selected on this board, these level shifters, I had to decide which direction they go in, and I decided to have them as inputs, which means that all the control signals and the data bus, well, the data bus actually, control signals are always inputs to this board. I've made the data bus inputs, which means that the transmit from the Psion Organiser that's here, will go through the level shifters and into one of the GPIOs, and I've got the PIO set up to do transmit and receive UARTs on 2 different pins here. I'm using the hardware UART to talk to the Wi-Fi module. So you've got the transmit coming in from the Psion, but this level shifter, I can only set the direction of all 8 data bits, and one of them is the receive or the transmit from this module back to the Psion, and that needs to be in the other direction. So what I've done here, and what you've got there on the back of the board, that is essentially a 1-bit GPIO line coming from the Pico. So I'm taking one of the Pico's GPIOs and I'm turning it into a, as it turns out, a sort of open collector tri-statable GPIO in discrete transistors. And that is the transmit from the Pico to the Psion. So I can have this level shifter doing everything, all the signals that way, which really is just the transmit from the Psion. And then my other discrete GPIO on the back here is doing the transmit from the Pico to the Psion. This is all just done because of the way that the Psion hardware is set up when you are accessing the serial port. So on the organiser it's port 2 of the 6303, and that has the capability, when you set up serial output or input, the data direction lines actually flip automatically to what they need to be to do transmit or receive, and that means I need to have the ability to have one of the bits in the other direction to the direction that this level shifter is set in. That all seems to work. What I can do actually, I'll plug an organiser in and I can show you how that works. So that's now running on the adapter but not on the organiser. Turn the organiser on, press the on key. You see there's a little bit of traffic on the display there. That's just the adapter being selected and the ROM being read out of the Pico. So the Pico here has got Comslink ROM image in it, and that can be loaded out of the flash on there through the level shifters into the organiser. And you can see that comms has appeared here, and that's the code inserting itself into the organiser operating system. If we select that and then we go to term, now this is set up for 9600 communication between the Psion and the Pico, because the Bluetooth baud rate is sort of irrelevant with the Bluetooth adapter. It's whatever the Bluetooth transmits at will be the rate coming in from the Bluetooth, and then it's whatever you want between these two. So I've fixed that at 9600. So here we have the traffic coming in from this adapter card. Now this is the garbage. Now I think this must be some sort of noise or something to do with the interrupt routine, and you can see that the data from the adapter is now coming through at sort of, well, roughly a character a second, 2 characters a second, and that is live from this adapter, and this is the test message that I'm sending, and that's going through the discrete GPIO circuit there, or discrete IO circuit. It's not really general purpose, is it? So that's all working fine apart from the rubbish at the beginning, and you could maybe get around that in code, but I'm hoping to be able to tidy that up a little bit. And the reverse also works. I can actually type on here and send those characters through to the Pico. It's just at the moment the only way I can see them is through Eclipse. So it's not on the display or anything at the moment. Could have a go at doing that. So that's all sort of working quite well. What I haven't got is the Bluetooth part of it. Now I can take that code out of the Organiser 2 recreation and port that over here. I do have a little bit of a problem in that at the moment I'm using both cores to do the ROM emulation, because this is using the sort of data pack code from the SD data pack that I did, and that used both cores because it needed to run pretty quickly to do the data pack ROM type emulation. And once you've loaded the ROM out of here, you don't really need that anymore, and the adapter and the interface works in a sort of modal way. You have these states on this interface. There's a state where you're reading from the ROM, there's a state where you're reading or writing from IO, and in the Comslink case, if the Comslink is selected, so the select line on the interface is pulled low, I think it is, then the hardware on this adapter is actually connected to the Psion, and that's how this code interacts with the serial port, the Comslink hardware. So because I know that this is all selected, i.e. the Psion wants to talk to the Comslink hardware here, then I think what I can do is actually stop all the code that is running flat out to emulate the ROM, because you know the ROM isn't being accessed at that point, and then maybe use the second core for Bluetooth communication with the adapter. It may be that I can just stick it in the loop that I've got here and have a sort of sub loop within the code and actually do it there. So I don't think there's going to be a problem. It's going to be a little bit tricky getting enough processing power in the Pico to be able to handle the traffic that's coming in and going out. Yeah, it's full duplex as well, so it needs to do both directions at the same time. The wireless module, that has quite a big buffer, so that buffers the traffic, and the hardware UART also buffers the traffic, but because I'm using PIOs, I'd have to do my own interrupt routine to do that. So at the moment that is polled on a character by character basis. But 9600 is the fastest that you can do, so that's not particularly fast, and I think that'll probably be okay. So that's the bit I need to do. I need to attach this code to the Wi-Fi room module. One thing that you can also do, which I haven't done but would be pretty simple, is have this traffic going out of the USB instead of the wireless module. So at the moment the traffic is just sort of stopping here. I've got some dummy code generating this test message, and anything you type here just sits in a buffer on this side. But you could just send and receive over the UART, and that would be pretty simple, and then you'd have a USB connection as well as a Bluetooth or a Wi-Fi connection, depending on what you do with that module. Bluetooth is the intended use case here. So it would be possible, if you could physically get that cable out of the case, that's one problem, to have this as a USB interface as well. And it all runs the standard ComsLink code. This is just running the code that is supplied in the RS-232 ComsLink. So that's where we are at the moment. This obviously is going to have to go and turn into a second revision of the PCB. I think maybe even a prototype PCB. Might be a little bit early. Well, maybe not. Might be a little bit early to go to a non-prototype version of this, something that's designed to fit in a case, but yeah, it might be alright. It's working pretty well. One problem is that this connector here, I'll pull that out, you're not supposed to do that, but you can see that the data's now FF effectively, it's all ones. The pins on here aren't as long as the pins that you get on a real ComsLink or any real top slot adapter, which means there's a sort of mechanical problem with fitting it in the slot. It's worked for me so far, but it definitely doesn't feel as secure as a real ComsLink adapter or whatever other bit of hardware you plug in there. So I think at the moment it's alright, and if you've got the extra plastic around there to slide in there, I think it's probably okay, but I'll stop that device missing because it's not there. So yeah, that's where we are with that.